Hey guys, in this video I wanted to show you the actual functioning of a real-life RC circuit. So what I've drawn here is the circuit diagram for the RC circuit itself. So up here is the battery. There we are. It's actually set right now to 4.5 volts. Maybe I should label that. The light bulb here is our resistor. And the capacitor is, of course, the capacitor. And it happens to be a 1 farad capacitor. I wanted it to have a fairly large capacitance so that the charging and discharging would be pretty slow. Otherwise, everything is over too quickly. So it's going to be a nice, slow process for you to observe. Now, the, quote, switch here is this wire. So when I move it to that position, that's going to correspond to plugging it in here. And when I move it to the other position for discharging, that's going to be when I plug it into the back right there. There's one other element to this circuit that is not visible on the screen right now, and that is these two things go to the voltmeter, which I will now show you. There's the voltmeter. It is a Pasco voltmeter, and the results of it are displaying over on that other half of the screen over there. Let's go ahead and set this thing to start collecting data. Alright, let me shift the screen around a little bit just so that the graph doesn't cover up the light bulb too much, because I'd like you to be able to observe simultaneously a couple of things. Number one, the voltage on the capacitor and the brightness of the light bulb. Because remember, what we've said is as the capacitor charges, the current will decrease. That should mean that the light bulb will use fewer and fewer volts and less power as well, and therefore get dimmer and dimmer. Alright, so I'm going to go ahead and hit the start button. So right now the volts register as 0 on the capacitor, but I'm about to plug it in to the power supply. Here it goes. And so right now you might be thinking, wow, that looks pretty linear. Well, I don't know, it's kind of curving down a little bit. And that's in keeping with what we said we ought to see, is a natural growth curve as the capacitor charges, right? As the capacitor gets more and more charged and uses up more and more of the volts provided by the power supply, the current becomes less and less, and that is in fact what we are observing right now. So right now the current is probably basically 0 because that capacitor is just about fully charged. Alright, let's stop it there. So that right there is approximately what a natural growth curve ought to look like, excusing this particular blip right at the beginning. Now let's go ahead and look at the reverse, okay? Meaning discharging. So that was charging. Now what we're going to do is we're going to discharge. So discharging is going to look like, if you recall, I said plugging it into the backside of the lead going to the capacitor. Let me move this screen over so you can see what I'm talking about. So I'm going to plug this in right there, and then that will move the switch from this position to that position. Okay? So it'll go from charging to discharging. All right, let's shift this back over, and I'll begin collecting data. All right, so unsurprisingly, it's displaying 4.5 volts-ish, and plug it in. And you can see, as it goes, right, the volts on the capacitor is decreasing because it's discharging, it's losing charge, but also the light bulb is getting dimmer and dimmer. If you didn't observe those features on this graph or the previous graph, meaning with regard to physically what is the light bulb doing, right, getting brighter or dimmer or whatever, mostly just getting dimmer, then you should back up and look at the other experiment where we were charging it. Okay, and that is just a classic exponential decay function. That looks absolutely perfect. Alright, so putting the two together, right, charging was the natural growth, discharging was the exponential decay. Okay, thanks guys, that's all I really wanted you to see. Thanks for watching.